Hi everyone, in this video I am going to introduce you to our rest of the year. We'll be solving puzzles the rest of the year. What this means is you'll open up a page like this that looks big and confusing, and where do you start? So what you need to know about these puzzles is they're not linear. You don't have to go in order. You can totally jump around the page. You could sometimes even start in this right hand corner and make your way up. So what this is asking, what this will ask for every time is we want our information about whatever pattern we're looking at. And there's 4 pieces of information we will want. We will want the equation, the specific pattern. We also want its visual graph, its visual representation. A lot of times we'll want its data table because we'll need to build our data table first in order to plot points. And last but not least, we would want a summary of its key features. So in this case, our clues for this pattern are given to us in the table, and then these same XY data points are labeled to us on that visual graph. So those 2 things are done for us. What we need to do is build the equation of the line. So we have some space to work to find the equation of the line down here, and this is actually where I started. I found my equation first. So I know that I have to start with my building block, y minus y1, a data point, equals m, the slope, parenthesis x minus x1. So I go off first and I find my slope, y minus y divided by x minus x. And I pick any data points I want in here. I think it would be easy to use one that doesn't have a decimal in it, and then I'll just use the one right above. So I have y minus y, careful, minus a negative. So that becomes negative 4 plus 4.5, which is positive 0.5. And then I have x minus x, 2 minus 1 is 1. So that is just 0.5 divided by 1, which is just 1/2. Now I just want to point out that I did some extra work just to show you. You don't have to use the 2 data points I used. You could use any data points and you'll still get 1/2. So for instance, if I did this y value minus this y value, it would be negative 5.5 minus a negative, so that turns into negative 1, negative 5.5 plus 4.5. And then x, negative 1 minus 1 would be negative 2, and that still turns into positive 1/2, the same as what we did before. So now I go back, I know my slope is 1/2, and then I'm going to use my easiest data point, x equals 2, y equals negative 4. So now I have the equation of my line, y plus 4 equals 1/2 x minus 1. Unfortunately, when we put it up here, it has a y equals, f of x equals, so I need to get y by itself. So I'll just add 4 to both, or sorry, subtract 4 on both sides. And that's also nice because now I know what my y-intercept is. My y-intercept would occur at 0, negative 5, which we could see on the graph right there. So the next thing I did was fill in my key features. My slope was 1/2. My y-intercept was at negative 5 because when x was equal to 0, y was equal to negative 5. I could see it kind of cheating here. My rate of change is just my slope, so that's also 1/2. I have my relating lines down here. A parallel line would have the same slope, and a perpendicular would have a flipped fraction made negative. And then I think the trickiest one, because it has us do algebra, is to find the x-intercept. So the x-intercept happens when y is 0. And so I would set 0 equal to my y value. And we can actually see where this would occur if it kept going. Bloop, the x-intercept would happen right about here. 0 equals 1/2 x minus 5. Add 5 to both sides and clear my fraction. Multiply everything by 2, and I get that it must have crossed the x-intercept at positive 10. This must be positive 10 over here, and the y value would be 0. So now I have solved my puzzle. I have found the equation, I have the graph, I have the table, and I have summarized its key features. And let's see if we have anything else to do. So it wants us to manipulate, do some algebra, and manipulate this to standard form, which is the x and the y term on the left-hand side without any fractions. So I can clear my fraction to start, or move my x term to the left-hand side by subtracting 1/2 x on both sides. And what I get when I move the x term to the left-hand side by subtracting it is, and multiplying everything by 2 to clear the fraction, is 2y minus x equals negative 10. So let's just verify that both of these are the same. We have on Desmos y equals 1/2 x minus 5. Oh, let's go to, there we go. I press home to get it back to the window back to normal. And then we also have 2y minus x equals 10. And are those the same line? Negative 10? Let's go back. Negative 10. Are those the same line? Yes, those would be the same line. They cover each other. And just to verify, let's double check that my x-intercept, yep, is 10, 0, and my y-intercept, yep, is 0, negative 5. You can usually click on your intercepts. If I wanted some more data points to put in my table, there are our data points when I converted that to a table. Last but not least, find the equation of the line perpendicular. When I'm finding the equation, I always start with my building block. It goes through the point x equals 1, so I put that in for my data point, y equals 0, so I put that into my data point, and since it's perpendicular, my slope would be the opposite reciprocal, negative 2 over 1, or just negative 2. So I could stop here, but I could also just say, oh, y minus 0, that's just y, equals negative 2x, and if I distribute the negative 2. So either version works, and we can verify this by graphing it on Desmos to double check that it's perpendicular. So I'd have y equals negative 2x plus 2. And that does indeed look like a 90-degree angle. It looks like it's running perpendicular to that line. So I have verified that on Desmos. And that is how to complete your very first puzzle for the rest of the year.